Okay, we're going to look at today another way to prove triangles congruent. We'll get two more cases, the angle side angle case and the angle angle side case, and see if those are shortcuts that can prove triangles congruent. Also take a look at doing some proofs using the different triangle congruent statements that we've learned. First one to look at is the angle side angle congruent statement, and we'll explore that one using GeoGebra like we did last time. Feel free to click the link on the website and explore this one on your own as well. Okay, so this is the angle side angle congruent statement because we have the angle, one side, and then the angle next to it. So the side is the included side between the two angles. So if I know that, I know I can't change this angle at all. So the only way I can change this triangle is to change the side lengths. So if I change the side lengths, notice I get sides of 9, 9, and 12. And there's no other way that I can create a triangle, as you can see, because this is the only spot that they're going to meet. And if I change the angles at all, or the sides, it doesn't matter, because these angles are locked in. They're the same distance away, and there's only one meeting point for that third vertex. So the angle side angle is a congruent statement that we'll look at. The other one we want to take a look at is AAS. You can probably guess what that one stands for. That would be angle, angle. So with angle, angle, side, we have two angles and a side not included between those two angles. So I want to see if I can create a triangle in this one. So I'm going to slide this side until I get a triangle. There we go. Add it. There we go. So here's my three angles and my three sides of the triangle. See if I can get a triangle another way. It's not going to make a triangle over there. But in order to create this triangle with this fixed length here, and these two angles which are locked in, it's got to be a certain distance away. And that's the only triangle that I can get. Notice if I change the side or the angles at all, still same thing is true. If these two angles are locked in, and AB is a fixed length, there's only one way to create that triangle. So angle, angle, side will be our other congruence statement that we'll take a look at today. So you can write that into your notes, the angle, side, angle congruence postulate and the angle, angle, side congruence theorem. So let's write down some information for that so that we remember it. Here we go. So angle A, so if two angles on the included side of a triangle are congruent to two angles on the included side of the other triangle, two triangles are congruent. So here's a way to remember that. The S is between the two A's, so the S is included between the angles. Angle A, angle D are congruent. AC is congruent to DF. And then angle C is congruent to angle F. So we've got the side included between these two angles. So triangle ABC would be congruent to triangle DEF. Okay, and then the AAS, angle, angle, side, which means that side is not between the two angles. So we call that the non-included side. So angle A is the same as angle D. Angle C is congruent to angle F. And notice BC is not between those two angles. It's congruent to a side EF. So in that case, the angle, angle, side congruence works as we looked at. So triangle ABC would be congruent to triangle DEF. That's which way we match up our corresponding sides and angles. Okay, so we'll use those two as we take a look at some proofs and proving triangles congruent. So take a look at these three triangles and determine if you can prove whether there is enough information to prove those triangles congruent. If so, state the postulate or theorem. If not, explain why not. Pause the video and start it when you're ready. So the first one, we have an angle congruent to this angle, a side congruent. We also have vertical angles. So that's another angle. So we have angle, angle, side. So we'd say yes, that is congruent by the angle, angle, side congruence. Okay, B, We know all three angles are congruent, but that's not enough information. Even though the angles are congruent, one triangle could be larger than the other. So AAA is not enough to prove it. We would have to know at least one of the sides. C, we got one angle, another angle, and this part is on both triangles, so that's a side. So the side is between two angles. So that would be the included side. So angle, side, angle, and that's one of our congruent statements. So we'd say, yes, that one is congruent as well. Okay, let's do a proof, a new kind of proof, a flow proof. You might find that these might be easier than the two-column proof. Maybe you prefer the two-column proofs. Let's take a look at how this works, and you can determine which way you want to write proofs. So flow proof is a way that we can put down all our information and kind of show how it all relates and how it gets to what we're trying to prove. And in this case, we're trying to prove triangle CBF congruent to triangle CDF. So that's going to be our last statement. The first thing we do is we just try to put all the information out there. And if we're trying to prove triangles congruent, we're going to try to prove that with one of our congruent statements. So side, 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 or side, angle, side, or maybe it's HL that we looked at last time. Or maybe we'll use angle, side, angle, or angle, angle, side. So one of those congruent statements is one we'll use. So let's start by marking what we know. Angle 1 congruent to angle 4. Okay, how do I know that? That's given. Okay. We also know that CF bisects ACE. That is given to us. Now, if it bisects ACE, what does that tell us? Well, what that would tell us is that bisectors split an angle in half. So CFA would be congruent to CFE. Or if we're writing here ACF, whoops, I did that backwards, didn't I? We'll ignore that. Erase. Sorry, ACE is the angle we're looking at. So if the line bisects that one, then ACF is congruent to ECF. Got to pay attention. So, and that would be just, that's a definition of an angle bisector. That's just what angle bisectors do. Okay, so we've proven now an angle congruent in both triangles. I might just list that here so I know what I found one of the parts that I'm looking for. And as I'm looking at the diagram, I notice 1 and 2. 1 and 2 and 3 and 4 are both supplements. And I can write that information down because that might be helpful later. So if they're both supplements, and we know that 1 is congruent to 4, well, I know 2 now has to be congruent to angle 3. Okay, so if angle 2 is congruent to angle 3, because they're both, because 1 and 4 are both the same. So if 1 and 4 are both the same, let's say they're both 50 degrees, just for an example. Well, if these are supplementary, then if this is 50, this would have to be 130. And if this were 50, this would have to be 130. So 2 and 3 would have to be the same because they're both supplementary to the same measure. Okay, so we've proven another angle in our triangle. So now we just need to find either another side or another angle. So I know 2 is the same as 3. So we're trying to prove these two triangles congruent, CBF and CDF. Well, the other thing I noticed in those triangles, they share this side, CF. That side is shared in both triangles, and that's the reflexive property. CF is congruent to CF. So that gives us a side. And that's one of the criteria that I need. I've got two angles and a side. So which one is it? Angle, side, angle, or angle, angle, side? I'll look at my diagram. The side is not included between the two angles. So that's going to be angle, angle side. So this should be triangle CBF congruent to triangle CDF by angle side congruence. We can just abbreviate it AAS. Okay, so flow proof works. We just put all our information out and try to show an angle congruent or a side congruent. And once we get all those, we can show that that proves that the triangle is congruent. Okay, so let's apply what we know about our triangle congruence and take a look at this problem. Read through it and try it on your own. Okay, so as we take a look at this, and drew a picture to help me out. You and your friend are about 75 feet away from each other. The angle from you to the flag is 72 degrees. Your friend to the flag is 53 degrees. Can we find the flag? Well, what this is trying to tell us or ask us is, is there only one triangle that we can form with this given information? I've got an angle, an included side, and an angle. So that would tell us that there's only one possibility, and as I'm looking this way, my line of sight goes 72 degrees. Your friend's line of sight goes at a 53-degree angle. They're going to meet in one location. So yes, there is enough information because we have angle side angle congruence with the triangle. So here's a recap of the different congruence postulates and theorems that we've worked with. We learned these two today, the angle side angle and angle side. Like I said, you've got the GeoGebra links that you can try those on your own. But then we also have these three that we learned last time, and we'll apply those as we continue working with proofs on proving triangles congruent. We'll see you next time.